Okay, we got a couple things here going on. So it's basically a transfer punch with a sleeve that I have made up for 5/8, and this is a piece of 1.5 that I was used for something else, and it just happens to work out for us fine here. What I'm doing is I'm scribing out a line that I'm going to hand sand these to. I mean, we could put these right on a rotary table and we can over engineer this radius here, which is just clearance for the bearing. The bearing will be sitting proud of the top of here and all the way there, as long as we give the 3/4 inch radius there, and they'll be just by hand. Alright, so to sand all of these, so I just basically come in here and describe a radius up here. All I need is partially on this curve right here, and then here, and then I'll be able to sand that right on my Wilton sander there. I'll do one side and then the other side. And what I do is I'm just marking these up with a line that I can scribe to. Now I come in and I sand one side, and I flip it over and I do the other side, but I want 4 lines so that I got references by eyeball. So I'll get all these scribed up, and then we'll go into the Wilton there, and I'll show you how I sand one in. And of course I've already done one, and this is what it's going to look like when it's all done. And then we got just some slight deburn on the inside, and this carrier tube will be ready to rock and roll. We're at our Wilton, and we tracked the belt so that we're all the way over close to this edge right here. Alright, and then we're going to take and we're just going to work in here, flip it, and work until we blend that radius right into our scribe lines, and it looks really good by eye to us. You hit a little bit there, and then when you flip it over, you're able to reach in a little bit farther for the other side. And you just make sure that you're not tracking too far with your belt to where you're cutting into your side cover. I don't normally wear gloves with the Wilton here, but the hot sparks and the heat of the tube really does get going. So I'm not close to it, so I'm just keeping it for protection here. You know, you can wear gloves or not wear gloves. It's up to you. It's not always the brightest thing to do, but you know when you're going to get your hands in there close. Alright, now once I have it like that, there's still just a little tiny peak here and there, and I want to blend those in with the hand sander. Alright, sometimes I use the top of this just for a resting point like this, and I can grab my sanders that I've got over here, and this happens to be plugged in already. Just a little massaging until it looks like a nice curve. Alright, we still got to deburr the inside and that. Ladies and gentlemen, welcome to Turn Right Machine Works, and my name is Keith, and we're getting ready to continue on with the Wright Roller Kits. Now we've pretty well shaped out this center tube. We do have a little bit of deburring to do on the inside and fit the next part, and the next part is where we're starting on right now. So let me put you in at the vise of the Bridgeport here, and let's get going with continuing on with our project here. We're running out of time. We have a lot of other things coming in here, and we're trying to carry as many jobs as we can, keep things going, but we're still getting ready to send these off to Stan's place there for the summer bash. All right, I've got a couple parallels in here. I've already kind of gathered up all my stuff to get ready to go here, so I am a little bit prepared, but I want to go through how I did prepare. All right, we have a couple parallels set so that I got the height. I'm comfortable with being able to grab the top of this part with my fingers, and enough is held in there to hold the part. Okay, now we want to hold this off the end there, and I don't have one of the little short block stops that normally clamp on here for a mid-vise stop. So, and this stop here is actually set with a rod that's not going to reach all the way over there. What I really like to use, and since I've actually had these, I actually stopped searching for that little block over here, because I have various sizes of these machinist clamps, and what I do is I take the clamp and I lay it down, I slide it up there, and then I go ahead and tension up the clamp with the two rods right on top of there. You're keeping it parallel so that face on the end is going to stay square. And then I take one of these screw-in scribes that had the used to have the end on it there, and you snapped off, and that's I use that to go ahead and throw on the floor. Okay, so I stick it in here, and I use this as my tensioner and get some extra tension on that piece there. See, now we can just throw that piece in and out. I had a small spring in there holding those parallels. You can take strapping, and you can bend strapping. You can create your own springs, but I never throw away a spring, and I have a big box of them, so it's kind of convenient to put that little spring down in there, and it leaves more open area for chips to fall down in there than a band strap or the automatic parallel holder, things like that. This happens to be a real narrow gap. I'm probably only about a ½ an inch in there, so it's a real short spring, but it's pretty stout, and it holds the parallels there. All right, so we're holding our part like that, and we're going to run all of this one edge on all of these blocks. We have 3 sets down here, so we have 12 blocks, and it takes 4 per each set. And we're building 3 sets, 1 for myself and 2 to give away at Stan's bash. All right, we lock that in. I need to put a cutter in here. Now I'm gonna use my, you see me I use turbos a lot, because most of the time these here I just need to have good height, good width, and then we're gonna go in and we're gonna form the radius that's gonna match the radius in here. Now I can well, let me blow it off. Okay, see how often I get this down and use these? I do have a full set of radius cutters in here, but I'm not going to take the time and do all of them, because this radius on this part is going to be stuffed in here, and then this is going to be welded, and you're never going to see that finished radius. So I'm going to hand do those on the sander, and when we go in there, I'm going to show you how fast I can put those on. All right, so anyway, we're going to put these aside. Some of the guys are using these, and on the outside corner of the uprights and things like that, I might actually use them, because we want a nice smooth finish, and that's going to be out in the open. But I'll do a couple that way, and then I'll probably sand a couple, and we'll see how that looks. All right, let's go ahead and let's pull this out. Okay, raise up the table. We always want room to get our quill out of the way if we have to, but we want it to be somewhat sticking down. But go ahead and bring up the table here to where we got pretty well a matched set combination of table height and also spindle depth there. Okay, yeah, I like that. That's good. Okay, let's reposition you because we're just going to get in here. We're going to be doing some facing off on these squares here. Okay, we're all set up here now. All right, we're going to turn our spindle on. We're going to come down. About yo. All right, now all of these are pretty well rough cut, and they're, some of them vary. There's a 2-inch. There's one 990, 980, 900. They're all rough cut. What we're actually fitting them into is 1 3/4 roughly. There's 153, 152. All right, so what we're going to do is we're going to touch off. First off, we're just going to go ahead and quickly measure the one we have in here. And we're about 920. Okay. So we're going to touch off on it. And we're just going to feed back here. What we're going to do is we're going to set it up so that we have something that we can judge. That was 920. We'll put in 0 here. And let's go ahead and we can go ahead and we can take 100. All right. A lot of the turbo windmills let you cut so easy, there's no sense in putting oil on it. And a lot of times they get asked why you use oil now and not then or whatever. With the turbo windmills, a lot of times, especially on cold roll here, you have no reason to really put in the cutting oil. If I was over on the K&T and I had a chance to run flood coolant and I can maintain that flood coolant flow, I would probably run coolant on it of that nature there, and that machine has got a nice comfortable reservoir and all of that. But the Bridgeport doesn't have all of that luxury, so I would I'm just going to stick to this method here. All right, I just back it out a couple thousandths and then come back into my my 100, which I'm going to go ahead and change over and set to a 0 right here. Okay, because that way we're at a 0 here, and then when I get ready to turn them around and face the other end off, I will go ahead and go from that point to what we want. All right, right here we're 825, so we basically have 75 thousandths to go still. So I'm going to run all of these through this process here. Just a little bit of air in there. That's another nice reason to have the springs in there. They hold it when you kind of hit it off with some air. The parallels don't tip over, fly up, lift up, and chips go underneath and stuff like that. All right, so we're going to continue going through all of these and hitting this one side here. All right, we got our 12 pieces set up here. We have the pre-machined surface all facing up, so that when we grab them, we'll be putting them in and making sure that we have the finished side here and our saw cut side out here. And let's just go ahead and we're going to probably take a cut and then we'll take a measurement anyway, but we're still at that 1 inch 820. Alright, I'm just coming in to, just barely touched it. Alright, 820, and we actually said 825 and it was like 75 thousandths to go. But I'm going to go ahead and I'm going to crank in 60, about 10 away from what we project it's going to be. Let's take a cut across here and then we'll measure it, see what we got. All right. little there. All right, let's just go ahead and we'll measure it, see what we got. And we got 1 inch 768 or so. So there's about 18 we got to come out of here, but maybe not quite as much. This is like measuring about 5 thousandths over 1 3/4. I think we'll take 10. What did we say this was? 8. Let's take 14. We'll see how it fits in there. All right. All right, there's the 14. Okay, there's 754. 754. Let's we just need to see if it fits in there, and I'm getting it to dip in there. That's going to be good. I'm going to go ahead and call that 0, and I'm going to go ahead and cut them all to that length right now. Okay, we're ready to go for the next operation on this. Their tail length, we get them to fit inside the edge of the box tube here. They don't have radiuses on the corner yet, so they can't slide in there, but we're going to do that after we put the holes on them, because we're still using a sharp corner to locate this part in here. Alright, so we want to put the 5/8 hole that's going through, and right here, 5/8 hole, and it's 1 3/8 up from the bottom of it, and there's about 1/16 of an inch of material on each side, you know, around on these 3 points right here. And so we're gonna have to be conscious about our parallels under that part as well, because that 1/8 inch is going to come down here and it's going to grab those parallels. So I'm going to push the parallels back in there a little bit. So it'll still locate the part. Now I'm going to go ahead and pick this up just to make sure that I am back out of the way. And I'm going to go ahead and I'm going to open this back up again once I locate my hole. All right. Now I got a wiggler in here. Let me see. A little bit fast. Okay, there we go. All right, let's come over here to the back side of this project here. I'm already dialed in 3/8 of an inch in from the jaw face, and we're going to stick the wiggler down in here, and then we're going to go ahead and come out until we kick. There, we kicked. We're going to zero that, and then do a retest. And it's zero again. Okay, that's a 200 thousandths tip, so we're just going to move it 100 thousandths and then re-zero it. All right. Now, you know, sometimes after you have it zero like that, if you wanted to, this is a quickie. Tap followers are a great thing because you can come down and you can visually see where you're at there. If you wanted to, you could go ahead and measure out here and put a scribe line. Sometimes I just take the scale and hold that. Ooh, I stopped on 1 inch 3/64, and there we go. There's another 16 there. 1.1375. Now I take pocket scale and stick it here, just eyeball it roughly, and I come down and I can see the pointer, and I can see that I'm, you know, at the one, just cross-referencing and checking periodically the time. All right, now let's go ahead and we want to make sure that we're clearing a 5/8 diameter down in there. And I have the clearance drill here, and we can stick it down in, and we know that we're about 1/8 of an inch away from our parallels, and this drill bit is pretty close to the 5/8. So we're going to have plenty of clearance there, and we have plenty of parallel to actually hold that down. The vise is going to hold that thing from twisting and cocking. All right, now we're ready to go ahead and start putting in our hole in here. And I'm gonna go see if I can hunt up my tight reamer again, and if I can, then that's what I want to put in there, because to be ideal, the round axle that will go down in there, the trunnion pivot, if that presses down in there, it's going to be a better product at the end. Okay, we've finished drilling all the 1/4-inch pilot holes, and now we're going to put in next size drill. We're going to lower the table down here. Okay, and we're going to have to slow down our speed here. I think that's going to be good. Now I may run some oil on this. Well, it looks like I did that in a drill grinder. Let me speed it up a little bit. And maybe 1/4 inch is a little bit light for that. Alright, let's get a little oil. We're not just going through a little thin layer now, we're drilling through a pretty good size plug here. That acts a little better. We might try another drill bit here. Let's see, what do we got on the round stock here? We had a piece around here somewhere. Let me throw it in here. All right, I even grabbed the one I already deburred. Okay, we're still tight there. Okay, we grabbed another drill bit out of our rack there and put it in here, and we drilled out one, and it really hugged it right nice, and it went in true, gave us a much cleaner hole. And then we went in and we just dressed the edge on it, because we were really seeing that we were cutting on one flute more than the other flute. And at the beginning it takes off and it actually cuts 2 flutes now, and then when it gets down in there it starts just going to 1 flute again. But it is turning true. See, there's 2 flutes, and then as it goes down in there, the one gets heavier and the other one gets a little lighter. But it's still doing a nice tight hole, and they're round. And so we're gonna go with this drill bit right here for the rest of the parts here. And we're on the verge of the pressure, the feed, the rate, and the speed we're running the drill, because we are somewhat getting a golden chip. Now it doesn't turn to blue or a darker color till after it falls, and that's what you want to look at when it turns color and where it turns color at. If it comes off of your tool bit or your drill and it's white or golden, then you're going to be in good shape. If it comes off blue and black, then you're going to be burning up your tip here pretty quick. But all right, we're going to drill the rest of these, and we'll come back when we got the reamer. We're going to pull out this drill bit here, and we need to pull out our chuck. we're going to change out the collet and the chuck to the collet and the reamer, because we finally got a hole to stick our reamer in. Alright, and I think I'm going to come up a little bit just so I don't have to go down so much. Okay, now we want to slow this down. We're just going to bring it down to 80 RPMs. That's the lowest the Bridgeport goes with the J head with the pulley. Alright, nice clean reamed hole right there. Let's see, did I leave myself? Oh, I left myself enough room. Okay. I wouldn't want it any looser than that. I couldn't find my real tight reamer. But there again, this coral stock here, I believe is just a little bit undersized. Yeah. 624 by my dial calipers. Alright, let's go ahead and finish reaming the rest of these. Okay, we're over here at the lathe, and this is item 6. There's quantity 4 of them, and these are the pins that go through the block and are the pivot of the main body. All right, in the drawing here it does say 1 inch 313. Basically 1 5/16 was what I had jotted down on my print, and these drawings were just taken from my drawings and then made into nice SolidWorks type of drawings here. And right now I'm just taking the rough pin at my length there, and the rough length that I have on this group of pins is 1 3/8. All right, and the way, because I weld these in and into the blocks there, so this is, I'm going to show you what I do and how I'm going to do it. So there's one smooth part off side on my pins, and then there's one that has a little nub there, and that's from the parting tool, and that's stuck on there. All right, so I take the nice end here first. Okay, let me zoom you in here. I'm going to do a little bit of work to both ends there. But right now we have the nicer of the two ends on the pin sticking out. So we come in and we're just going to just kiss that. It is a chamfer. It could be a radius. It could be whatever you want on here. Because that's going to be the inside, and that's going to be the end that I'm going to weld. So it really doesn't matter what's there, because it's going to become molten here soon. All right, now the side that has the part off, I'm going to go ahead and I'm going to dress the little chamfer on here. With this up close, you can actually see how much run out my 3-jaw actually has. All right, so a nice clean face, and we face that nub right off the end. And I want to add just a little bit more. I just didn't quite give it enough here. And that's just to dress out, because this is going to be outbound side to the air, but it's going to be sticking through. It's going to be sticking through the plate on the end. So, you know, a little bit of that chamfer is not gonna hurt. All right, so we're gonna finish dressing off the rest of our pins. And we'll run through another one here real quick for you. There again, our length on our, the final length that we're actually just kind of, the ballpark length I should say, is right around 1,350, 1,375. The setup that I'm going to set them up in, that I'm going to weld them into the block, will make them all stick out exactly the right distance from the tube shape when they're mounted in there. But for right now, they don't have to be that exact. The reason why I face off one end all the way is just so I have a nice flat, because I'm gonna jig it up off of that face right there to give it the height in the other piece.